I did the taping for the online version, and I developed all the materials for it. And the online students don't have TAs, they don't have Friday morning help sessions, so I did a sample project, full, complete sample project for each of them that's somewhat similar to the projects that they have to do. And so this one was for that. The fourth sample project was a remote code analysis. Model being something like a software repository, but a QA, testing tools that QA would use to test code. So here, if I click Analyze, up comes the code analyzer, and then pops up the result. That's the result back in the GUI. So what happened here was on the server, we ran the analysis code. So the client sent a message to the server to do this analysis. The server did the analysis and then sent back a message when the analysis was done, sent back a message with the results, which is this log file.txt. And then the client has a client proc that is triggered by that message coming back and pops up the analyzer in the code window. Let's go up one more and you can see it running a little longer. If we analyze this bigger thing, we can see it. Now, 2 points about this. The reason I'm pulling this up and talking about it is there's 2 points I want to make. One is, it's surprising how fast things happen. Okay? That analysis ran and bam, up comes the code pop-up. As soon as it's done, bam. It wasn't wait and then pop, up it comes. Okay? Very quick. When I first started doing message passing communication, I was concerned about it. Is it going to be a whole lot slower than RPC? So message passing communication is very desirable in that, if you use remote procedure calls, you're welding to the communication channel features of the application. RPC is function calls, and those function calls are specific to the particular application. So every time you have a different application, you got a different communication channel with RPC. What message passing has done is taken that application-specific stuff and moved it out of the channel. So now the application-specific stuff is all messages that are being generated and interpreted on either end. And the communication channel is just passing messages and files back and forth. That's all it's doing ever. Okay. So it's a very desirable thing. Communication channels are one of the harder things to get right. You know by now. Okay. So, something I was going to say and I lost the track. So anyway, it's surprisingly quick. The other thing is with the message passing communication, on the server side, for each message, there's a server proc. On the client side, for each message, there's a client proc. And it took me about 2 hours to add this remote analysis to this demo. About 2 hours. Why? Because it was simply a matter of design the message, design the client proc, design the server proc. I'm using the process that I gave you for the popping up a notepad window. I was using that process to run the code analyzer, and I didn't make any changes to code analyzer. Code analyzer just as it's always been. I'm just running that code analyzer. I'm not running the GUI part, I'm just running the analysis core part. So really, really, really quick and easy. Nice scheme. Okay. So with that, let's put that down. And now let's pull up this. So now we're going to talk about I/O streams. So let's do this presentation. It's all of 3 pages. What's here in this presentation is a diagram with some classes and a description of the classes. We're just going to look at the diagram, and I'm going to say the words that are on that previous slide. Okay? So there's really 3 parts. I/Os is responsible for formatting and error management. Stream buffs are the magic that connects your program to the outside world, to the operating system. And these classes are all user interface. So it's formatting and error control, buffering to communicate with the operating system, user interface for your programs. And the formatting is really simple. All of the formats in streams are contained in one long. And you think of them as just bits being set and reset. It's a little more complicated than that because there are several formats that have 3 choices. Adjust field, left adjust, right adjust, and internal. Internal means the stream's going to have some control over the way it's done. Handling floating point is fixed point. Scientific notation, and the streams decides. In those cases, I think there are. Those are the only 2 I'm remembering right now. It seems to me there's one more, but oh yeah, hex, octal, and decimal. Okay. The way that's handled, there are 3 bits associated with each one of those. So the 3 choices, so it can't represent a single bit. So there's 3 bits associated with each one of those choices, and that opens the possibility for getting more than one set, an undefined behavior. What does it mean when both left adjust and right adjust are set? Okay, undefined. So there's a function in I/Os that accepts, it's called flags, and accepts both a bit pattern in terms of an enumerator like left. I/Os : left is a bit for that left, but also an adjust field. And the adjust field, when you pass an adjust field, that clears the 3, it tells it which 3 bits to clear, and then the other one sets the 1. So that way, that takes care of the problem of more than one being set. Okay? As long as you use the set flags with 2 arguments. So, and errors are also quite simple. There are 4 error conditions: good, fail, end of file, and bad. So good means everything's fine, it's going to work the way you expect it to. Bad means that some condition has occurred and the stream will no longer listen to you. Reminds me of my son when he was a teenager, okay? Ask him to take out the garbage and he would say, "Yes, Dad," and then never do anything, okay? So in order to get him to do something, you got to clear him. Fail state is the stream has been corrupted. You aren't going to ever get it to work right again. All you can do is throw it away. So, so there's good, bad. No, I'm sorry, I said it wrong. Fail means that some condition has happened. The stream is okay, but some condition has happened that it won't proceed until you clear it. That's fail. Bad means the stream has been corrupted. And end of file is really another bad state. So anyway, fairly simple error control, fairly simple formatting. We're going to go through all that today and look at code examples. StreamBuff, this is not an abstract class. This is a fully functional class that manages communication between the keyboard and the terminal and your program. Input stream buffs and output stream buffs and so on. File buffs are for connecting to files. String buffs are connecting to internal strings in memory that have a stream interface, and they're really, really useful. I use them all the time. Standard I/O buff is to share a buffer between C++ I/O and C I/O. Normally, they have 2 separate buffers. So if I use standard in and C out in the same program, understand that very often we'll compile some C code in the same build with C++ code. Okay, so you may well have both standard in, as well as streams, but they will have 2 different buffers, and so your output will not be necessarily in program order. What happens, these are buffered, and what that means is that as soon as you enter something in the stream, it doesn't mean it's going to go to the destination. It means it's buffered up until the library and the operating system believe that there's enough in there to be efficient to send it out. Okay? It doesn't do it character by character by character. It buffers some stuff up, and then it'll eventually send it out. And so if you've got 2 different buffers, it opens the possibility that I put an input, put an input, put an input, put an input. This guy says, I'm ready to go, but this guy isn't ready to go yet, so you don't necessarily wouldn't get it in program order. But if you use a standard I/O buff, you can share that, have one shared buffer between the 2. Okay, notice that I pointed this out when we talked about multiple inheritance. There is a multiple inheritance loop here. IOStream really does nothing but pull together iStream and OStream. Okay, so this document is an attempt to provide the complete interface, everything you could ever possibly do with streams. So it's taking that class diagram and breaking it up into parts. So this is just the input part for iStream. So it's a stream buff, iStream, iOS. And I've given the interface for iStream and iOS. It's clear because of this public inheritance that the iStream interface includes the iOS interface. Public inheritance, language guarantees that whatever the interface iOS has, iStream will have as well. So, but why would I include the interface for StreamBuff? It turns out that iOS has this readBuff function that lets me get the StreamBuff pointer. And with the StreamBuff pointer, I can call any of its functions. So that means that I can use the interface of any one of those in my program if I choose to. Normally we don't, but there's a couple of uses for that readBuff pointer that are very effective that we'll talk about in a couple of minutes. So, this is a catalog of those functions. And one thing you'll notice here is in the iStream end, we have the insertion operator and a whole bunch of other stuff. The insertion operator will edit the stream. For example, if there's leading white space, it'll throw it away. And it does other editing. It may expand or contract. If you have /r/n, return new line, it may compress it to just a /n, new line. Depends on whether you're Windows or Linux. Okay. So, but these guys, the get, read, get line, get, the various overloads of get, don't edit. So if you really want to see a faithful replication of each of the characters in your stream, you'll use get or get line or whatever. Putback is interesting. When you're parsing, very often you want to look ahead and then push back. You decide, I don't need that character. Okay, that really belongs to the next thing that I want to parse, and so you can push it back. But you can't successfully push back more than one. It's not a stack or a queue. It's not. It's a single memory location. At least all that the standard requires is a single memory location. So I can put back one character, and that's all you can count on. So if you push back two, so if I push back and then read, I'll get whatever. The first thing I get when I do a read is that character that I push back. So if I push back, read, push back, read, push back, read, everything is happening the way you would expect it to. But if I push back, and then read, I'm just going to get that second pushback. And I would have lost the other character. So you got to be a little careful of that. Seeking and around these are for moving around the buffer. Basically what they do is move the buffer pointer without you actually pulling anything into or out of the buffer, and you'll see me use it. Mostly we use it with files. iOS, these are the, so now notice, for example, here's the read buff. This gives me access to the stream buff. Flags returns the long that represents all of the formatting. And you say, why do that? There's flags and there's flags that take along. And you say, why do that? If you're writing code for a class project, you own the process. You can do anything with it you want. But if you're writing professional code, you don't own the process. The guy sitting in the next cubicle to you and you are writing code for the same process. If you change the formatting and don't put it back, you'll break his code. You may break his code. One day you'll hear somebody come stomp, 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 stomp down the hall. Bam, 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 bam on your door. You broke my code, you broke my code, you broke my code. Okay? And in some organizations, well-run organizations, whoever breaks the code is a goat. They get to run the build process for the next week. And that's boring, and it means you're there 3 o'clock in the morning, you know, running the stupid build process. So you don't want to break the build. So the point is that I can say flags and get the formatting state, and then change it to whatever I want, and then push it back. And it restores it. So I save the state. You know, the state in this particular development might, the default state might not be what's default for streams. It might be some, initialization that was done to suit everybody. So whatever it is, you pull it out, change it, and then you push it back. Width is interesting. Width allows you to specify a field in which you are writing or extracting. And so, for example, if you're writing into a field of 3 and you write 2 characters and you do that twice, you'll have a space in between. You'll have 1, 2, space, 1, 2, space, 1, 2, space. The interesting thing about width is that all of these functions make persistent changes to the formatting except for width. Width persists only for the next input or output, and then it reverts to default, always. So if you want to write a bunch of fixed widths, every time you write, you got to use that width statement. That's not true of the other formatting. You test the stream state with end of file, good, and you can clear it, and you can. I'll show you that you have to clear it once it's gone not good if you want to use it anymore. And there's low-level stuff, bump C and put C and stuff like that, for which we normally don't use in our programs. I'm going to show you a little bit of it, but we normally don't use it. So that was input. Now, I've gathered together a whole bunch of enumerations. I don't know of any place other than here that you'll find all these put together in one place. Those formatting flags, for example, hex and left and show base. Show base just says if it's hexadecimals, you'll show the X. If it's octal, you'll show an O. And show point says if it's floating point, if it's 3.0000, by default it'll just print 3, but this says, no, give me the decimal point. And uppercase is interesting. You say, oh, good, I can make all the characters uppercase. No, you can't. All uppercase does is it makes the character, the base character in hex and octal, capital. So from instead of a little x, it makes a capital X, or instead of a little o, it makes a capital O. That's all it does. All it does. Okay, and state, good bit, end of file bit, fail bit, bad bit. So, and input, output modes, seek, beginning. So this says go to the beginning of the buffer, go to the end of the buffer, tell me what the current buffer position is. And there's manipulators. Now these manipulators, most of the functions that I can apply to a stream have a corresponding manipulator. So there is a function hex. I can say cout.hex, and it'll set it in hexadecimal mode for numeric output, for integral output. But I can also insert hex. And I'm not inserting anything. The insertion and extraction operators are overloaded to accept a function pointer. Aha. So when I insert this hex, I'm just calling a function on that state, on that stream, to change the state to hex. Okay. So manipulators are just functions. Some of them take arguments, some of them don't take arguments. And you can write your own manipulators if you want to. Nice and easy to extend. this is the output for the top level. So iStream was for pulling stuff out of the keyboard. OStream was for writing stuff to the terminal. And, you know, basically the same complement of instructions, only they go the other way. There are now, I've included IFStream. So this is the part of the class diagram that I am representing on this page. But now, I don't show all the stuff above. I'm not showing iOS and iStream. I show IFStream, and anything that I'm overriding here or here, I'll show. But there's some functions in iStream and OStream that you won't see down here. That means they're just the ones you saw on the earlier pages, and I didn't repeat them here. Okay, so these are just things that have changed when I go to this lower level. Okay, and it's, you know, open, attach, close, you know, some new functions and some functions that are the same, but that are really overrides of virtual functions in the base class, and so on. OF streams, string streams are really useful. They are strings in memory, and one of the things they have is a string function. So I can create a string stream. I can push stuff in using insertion. I can pull stuff out using extraction. And when I'm all done, I can get the internal string just by calling .str on that string stream object. These are really useful. Understand that when I write to the terminal a floating point number, 3.14159 pi, approximation to pi. What I put in is pi. What I get out is not pi at all. It is the character 3, followed by the character point, followed by the character 1, 4, you know, blah, 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 blah. So what I've done is I've done a floating point to string conversion. I've got the string representation of that floating point number. So I can use string streams to convert between floats to strings, ints to strings, and I can go the other way, which I'll illustrate for you. And in fact, if you use my convert facility, in the utilities, there's a little convert class that has a toString and FromString function that just uses IOStreams. That's all it does. Okay, so that's the entire interface. There's nothing, when you combine what's here with what's above it, absolutely every single function that you can call on IOStreams is in this reference. Now, I haven't explained them, but you can see what it is you can call. You know, most of them are fairly obvious, and if it isn't obvious, you can do a quick consult Dr. Google and find out exactly what it's doing. Okay, so let's look at some code. Oh, I don't want to do that. So let's look at formats. So come on. So formatting integers. So here, notice I'm saving long save equals cout.flag. So I'm saving the formatting state of cout. Set flag, IO's show base, IO's uppercase. So this says show the base character. I'm going to write out 59 as in decimal, hexadecimal, and octal form. Okay. So, so I'm going to show the X and the O, and I'm going to make them uppercase. That's all uppercase does, is make those X and O's uppercase. And then illustrate that, and then save the state, resave the, push back the original state. So here's my 59 in hexadecimal is OX38B. 59 in octal is 073. So, so these are caps, and they're here because I called show base. Okay. Otherwise, I would have just gotten digits. Okay. Now, formatting doubles. Cout precision 6. So for a lot of years I did scientific programming, and I know really well what precision is. I worried a lot about precision. When you do scientific programming, very often algorithms tend to be ill-conditioned. They subtract two very large numbers that are close to each other to get a small number. Very common in image processing, digital signal processing, and stuff like that, those kinds of algorithms. So precision is really important. Maintaining precision is really important. So it's the number of reliable digits in your code, in your output. That's what it is. Number of reliable digits. It's not what IOStream means. What they mean is the number of digit positions after the decimal point. Has nothing to do with precision. It's the number of digits I'm going to display after the precision. They might be totally irrelevant, totally garbage numbers because they were outside my precision level. Okay, but they chose to call it that. So anyway, 6 digits after the decimal place. Set flags, IO's right, IO's adjust field. So here's the case where I can adjust right, adjust left, or auto. It's either auto internal, I've forgotten which. And adjust field, having this here says clear those 3 bits and then apply. So clear these 3 bits of the adjust field and then apply that bit. Set that bit, the right bit. Okay. IO scientific. Set F, IO scientific, IO's float field. So this again is 3 fields, fixed, scientific, and internal. Internal means I'll decide, streams will decide. And IO show point means I'm going to show the decimal point always. Now I'm taking 9 and I'm dividing it by 3 and displaying the results. So let's take a look at that display. Remember, our goal here is simply to format those numbers. So here we have, notice 6 decimal digits, all in scientific notation. So normally it wouldn't print this E plus 00, okay? But because I told it scientific, I'm telling it I want that. And so, here's 3, then divide by 3, then divide by 3, then divide by 3, then divide by 3. Okay. So that's that. Now I'm going to adjust and fill. So I have an array of strings 0, 1, 2, 3, 4, an array of integers 0, 1, 2, 3, 4. I'm going to set a field of 30 digits, 30 characters. When I use a fill of dot, that means any place that would have been a space put a dot. But don't overwrite something that isn't a space. Just where there were spaces, put a dot. That's what fill means. In other words, do this first and then write whatever you're going to write. Painter's algorithm. I'm sure that's what they do. So now I step through these 5, 0, 1, 2, 3. So I'm putting 0 left adjusted in a field of 30, and then this 0 right adjusted in a field of 30. And notice I have to say 30 both times because this isn't persistent. All the others are, but this isn't persistent. The width isn't persistent. So, and these are manipulators that take a input parameter. Now, by the way, it's a callable object that takes a parameter. So here's what we get. Okay, just fill and width, 0, 0, 1, 1. So this is just, you know, adjusting and filling, and away we go. Stream manipulators. So now set precision, set fill. So some of the things I did here with functions, now I'm doing here with manipulators. Same kind of thing. So I'm just showing you that most of anything you can do with a function, you can do with a manipulator. And so, sure enough, you know, I'm manipulating these, I'm filling in, you know, blah, 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 blah. Okay? That's formatting. You now know 95% of what anybody knows about formatting I/O streams. You do. It's simple. That's all there is. Okay. Now let's look at file I/O. So here I'm going to take the last argument on the command line and try to open it as assuming this is the last argument on the command line, I'm assuming that it is a file name, and I'm going to attempt to open it. Now, it's my responsibility to test for whether that's good. It might not be good. It might not be good because there is no file with that name. It might not be not good because there is a file with that name, but somebody has already got it open. Okay, so it's locked. So can't open it. Otherwise, now I'm going to create a string in memory with a stream interface, temp, and now I'm going to insert into temp, and I'm just assembling different parts. Processing file, here's the file name, using stream.getLine. It's a handy way of formatting up a line. And I display it, print it out. Well, in.good, in.getLine, buffer, buff size, cout, buffer, endl. Notice that this is in a anonymous scope, and let's just see what it displays. And so sure enough, here it is, first line, second line, third line, fourth line, fifth line, sixth and final line, and that's what it, okay, we just printed out. Now, because that's in a lower level anonymous scope, I can redeclare these. So here, same name, perfectly okay, because the other one was declared in that lower level scope that's now gone. Okay, same name, building up the name the same way. Now, I have stream in of argument argc, file buff, buff pointer equals in.readBuff. I'm getting a pointer to the buffer, and now I just say cout, pointer to the buffer, endl. I just streamed that entire file to the cout. It's just like you putting a literal string to cout. You put a literal string, it keeps pushing a character, until it gets to a terminating null. What it's doing with a file buff is it keeps going until it gets to an end of file marker. Okay. So I just, wham, pushed it out. So first one, here's the second one. This is, I'm using the read buff. There it comes. Okay. Now, open the stream again, seek to the end, find the file size, and back up halfway, then send the last half to standard out. So I want to send the last half of the file to standard out. So I open it, seek to the end, so from the beginning, go to the end, and SP equals in.telg. This is a bookmark. It's really the number of bytes in my file. Stream position has a bigger size. I think it's 64 bits, you know, so you can represent really big files. Telg, just it's a bookmark, if you will. Now, seek G to SP minus 2 from the end. So I'm seeking from the end back. That's why this is minus. I'm seeking back halfway. Now, that's probably got me in the middle of a line. So I threw away that first line. I read the next line and threw it away. So I don't have that half a line. Okay? And now I print it out. So processing left half of this 106 byte file. Fifth line, this is the sixth and final line. So somewhere in the fourth line, probably right at the beginning, was that middle marker. Okay. Okay. Now, so now, stream state goes bad when attempting to read past the end of the file. So this got me to the end of the file. And what happens is when I stream it out, the file pointer is moving. With each character that comes out and goes into the output stream, it's moving the pointer one slot. So now, char ch equals in ch, okay. So this was, this was an input buffer. So if in not good, attempting to read past end of file makes the stream state not good. So I was sitting right at the end of the file, and this read read the end of file marker. And that made the stream state go not good. Okay? It's a fail, but not a bad. It didn't destroy the stream. It just put it in an error state. Now, streams, not good streams, are just like your teenage son. You tell them to do something, they won't do a thing. They don't do anything. I used to tell my son when he was a teenager, take the garbage out. And he'd say, sure, Dad, and do nothing. Guaranteed, he would do nothing. Okay? So, streams are the same way. Once they get in this not good state, you can command them all you want, and nothing happens. Nothing. This streams are buggy. I'm writing this. What's happening? Because it's in a bad state. So what you have to do is clear it. So now in.clear. If in.good, now I print out. It's clear. I'm sitting right over that end of file character. But by clearing it, my stream state goes good. If I do a read again, it'll go bad. But what I do is I seek back one character. And now I'm going to read the last line. The last word was line, L-I-N-E, so I'm going to read an E. Okay? So now, if in.good, after backing up and reading E, stream state's still good, now I try to read one more time. I'm sitting over the end of file. Now I read the end of file, and my stream state goes bad again. So let's run it. So stream state goes bad when attempting to read past the end of file. Attempting to read past end of file makes the stream state not good. So you only see this line here if the stream state is bad. Because I tested it, and if it's not good, I print that line out. And now, can't read anymore until we clear the state. So I cleared it. Stream state good after clear. I backed up one and read this E, the last letter. Okay, I read that E. Stream state still good, and now I attempted to read it one more character, and now end of file state not good again. Okay, so there's to it. Piece of cake. File streams. You know almost everything there is to know about file streams. You do. Piece of cake. Okay, so now let's look at file buffs. So we're going to go a little lower level. Demonstrating use of stream buffers with file I/O. So I declare a file buff, input file buff, okay. File buff, IFB, IFB.open the last argument for input. Okay. File buff is a file buff, but as soon as I open it for input, that says that attach the receiving end to the keyboard, okay, or to a file in this case, to attach it to the file. And now, cout address of iFile buff just streamed the whole thing out. Bam, the file went out. Okay. Using stream buff for output to standard out. So now iStream, I'm going to build an iStream around this buffer. Now I have an iStream. Okay, so this iStream is this file. You know, so I opened a file with a file buff. So now this input stream is attached to that file. And now I seek to the beginning because it was at the end. As soon as I streamed it out, the pointer is at the end of the buffer. So now I got to seek back to get the file pointer back at the beginning. And now ostream out equals cout.readBuff. I just stole cout's readbuff. So now my out is cout. I don't know why you do it, other than as a demo, class demo, that you can do it. Okay. So now out, pointer, and I just send it back out to cout again. Okay. So using stream buff for input from file, using stream buff for output to standard out. Okay, so this is what I just showed you, and now using stream buff using low-level stream buff interface. So here I'm just showing you that I can use the sbump C and sput C, the really low-level character manipulation stuff on the stream. If I wanted to. Why would you'd never do that unless, except maybe you're writing a device driver or something, okay? That's the only reason I can think of you really want to use that. But, you know, the streams use it. Okay, so cool. So now, we've done a file I/O, file buff formats. Let's look at string I/O. Really useful stuff here. So here, I'm declaring, so the constructor of an input stream, I can give it the string. So this just puts the string inside the stream buff in memory. If I didn't give it any arguments, it would just be an empty string. But now, because it's an input stream, I can read out of it. So here, source.string, I'm just pulling, I put the string in the constructor. This function pulls the string out, copies it out. It's still in this, that string is still in the iString stream source, but it's copying it out and I display it. Now, OString stream destination is an output string stream, so now I can push this source into the destination. Okay. And I could have done that too. That would have worked. Source pushed into the destination. And I can take string buff destin.readBuff, and so I can say cout source.string, cout destination.string, cout pstring buff string. 3 different ways of doing the same thing. And here it is. Source, destin, string buff. Okay. Now, let's parse the input buffer. So remember that I put into this buffer an integer, a string representation of an integer, a floating point, and some words. So now I'm going to say int I, double D, and I'm going to say source seek back to the beginning because I streamed it out. Now I'm going to say source give me an I, and then give me a D. And it's going to work just fine. I'm going to get 15, and I'm going to get 3.1415927. Okay. And now I can extract those words, source into save buff, cout, you know, blah, 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 blah. This is going to take me, what this does, what this extraction does, will take me to each white space. Take that act as a delimiter. And so when I do that, what I get is, sure enough, I get I is 15, D is 3.14159, save buff is the hour. I built a little tokenizer. You know, really simple. It doesn't do all the stuff that we need a tokenizer to do, but that's a little simple one. And, you know, I don't know what I'm doing there. What am I doing here? Character by character parsing. So source.clear, seek G. While source.good, you know, I'm using gets. Now this is going to do an unform, you know, it doesn't edit it at all. If it's a space, you know, if it's not a space, I add it to temp, and I'm displaying it. So I'm just, you know, it's another way of parsing it out. So sure enough, I parse it out. Now, I indirectly illustrated one of the really useful points about string streams. So when I write, I may have said this to you, I don't remember, so I'll say it again. When I write a floating point number into an O stream, like cout, I start with a floating point. I have on the program side a floating point number, pi. On the output side, I have a string of characters, 3.1415927, okay, characters. So that string stream has converted a floating point number into a string representation, or an int into a string representation. That's the basis for my little convert utility. I have a toString and fromString, okay, just using iostreams. That's all I'm doing. Really useful. And by the way, you know, if I build some kind of construct, maybe a list, if I define for my list construct an insertion operator, I can immediately convert that into a string representation of the list just by inserting it. Yeah, cool. Okay. Last bit of code I want to show you is read-write. I'm going to show you that I can read and write at the same time to a file. I don't mean concurrently, but I mean I can open it, and then I can read it, then later on write it, read it, write it. Why would I ever want to do that? Why would I want to both read and write to a file? Sounds wacko to me. Why would I do it? Suppose you're building a record manager for a database. Database is just a file. When you get down to the bottom of it, it's just a file. That store is just a file. SQL database, just a file. And using the schema, I'll come in and I'll overwrite. From this byte to that byte. It's all exactly defined. The boundaries are exactly defined. That's what the schema's job is, to exactly define the boundaries for those fields. So sometimes I'll read it, sometimes I'll write it. Same file, only open once. You know, when I made my connection to the database, it only opened that file once, and I'm reading and writing to it. So record manager for a database is one reason, one place you might do it. So let's see how you might do that. So now I am going to alter my test file. And you really want your tests to be repeatable. It is an error to make a test that isn't repeatable. All tests should be repeatable. Every time I run them, I should get the same answer as long as I haven't changed the code. So in order to make this repeatable, what I do is I'm going to create a copy of the file, and then I'm going to work on the copy. I'm going to modify the copy. So my original, I haven't changed it, so the next time I run this code, it'll give me exactly the same processing. So now I just say iofstream master in the file name, ostream temp out, and I'm going to call it temp.temp, and then I just, I know this will work, a little demo. I should be testing these streams, is it good or not, but I've opened this a whole bunch of times in these demos. I know this is good. I know I can do this. So now I just say master in.readbuff into temp out. So I made a copy. Bam. One line of code. And now close master in, close temp out. Now open for input and output processing. iofstream in, temp.temp, ios in, and ios out. Now, I only get the interface for input, but I have the ability to both read and write to this buffer. Okay, and I test to see if it's good, and it is. Now, I'm going to create ostream out around the same buffer. I'm going to take my in.readbuff, and I wrap an out stream around it. So I have an input stream and an output stream wrapped around the same buffer. That's the whole thing. The buffer has both read and write permissions, and I've got an input stream, so I get the reading interface, and I have an output stream, so I get the writing interface. Okay, so away I go. Now, so I display the original file, temp.temp, and now I'm going to append this text to it. This text is added to the end. Now I read the number of bytes because I'm at the end, so stream pause is going to give me the number of bytes in the file, and now I just seek back from the end to minus that number of bytes. I could have used a single argument that said begin, but this illustrated that I can seek both backwards and forwards. That's all it's illustrating. So this text overwrites the beginning of the file. This is not an insert, it's an overwrite. Overwrite. Okay. And then write it out to see what happens. So this is first line, second line, third line, fourth line, fifth line, sixth and final line. That was my text. And now this text overwrites the beginning of the file, and it went up to the third line, okay? It just overwrote. So it obliterated those new lines because it just overwrote them. So they're not there anymore. Those first new lines, okay? And now here's the, this text is added to the end, so I'm writing to it. So I only opened it once, and I'm both reading and writing to it. Just like we do. So if you want to write your own MySQL, not your SQL, MySQL, okay, you can. Piece of cake. You now know 90% of what anybody knows about IOStreams from the outside. You know, there's lots of stuff going on the inside, the design of file buffs and stuff. So well, I'm only showing you a little tiny bit of that. But the way it's used, you know, if you go to that reference I gave you, every single function you can call is listed there. I didn't give you the definitions for it, so most of them are obvious. You look at them, and you know. But you know, if it's not obvious, go consult Dr. Google, and you know, with a little bit of filtering, it'll give you good answers. So you've got the entire interface, and you've seen how it all works, and that's it. That's everything. But you can do virtually anything. You know, if I wanted to, I could make sockets with a stream interface. I tried that once, and I got annoyed at it because you know there's a lot of little tinkery, low-level stuff you got to take care of, and you know the stream interface I don't think is really a good interface for sockets. Was my final conclusion. I might change my mind about that. You know, maybe my set of ideas just wasn't good enough to, you know, but who knows. I don't think I would explore that anymore. Okay, that's IOStreams. Wow. Cool. There's some stream iterators. Let's go take a look at the stream iterators. This is in 687 code stream iterators. So let me go there. Stream iterators. Stream iterators are a little odd. Stream iterators. Oops. Okay, so so here I am opening this, our old friend, you know, named on the command line, and testing to see if it's good. And now I'm declaring an iStream iterator of type string, okay, inString.in, and OStream iterator string outString.cout, while in.good contents of outString plus plus equals contents of inString plus plus cout. Now, see, notice my outString, my input string iterator is tied to this file that I opened in. But the output string iterator is tied to cout. So I'm just going to push what's in cin to what's in the file to cout with these iterators. And I'm just using iterator, you know, syntax. Plus, 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 contents, contents. There we go. Okay. Basically what I'm doing is iterating through this file. Okay. So, and it's what it's doing is it's breaking on white space. So, I don't use stream iterators much. I find them a little counterintuitive or something. I don't know. They just don't fit with my mental model or something. I don't know. Let's see if there's anything here we want to look at. Nah, nothing much worth looking at there. Let's look at iter2c. Yeah, let's look at this. So here, I'm declaring a vector of strings, and I'm pushing back first line, second line, third and longer line, fourth and last. And now OStream iterator of string, outstring cout. So I'm binding that to cout. Copy, I'm using an algorithm, copy test.begin, test.end to outstring. First line, second line, third and longer line, fourth and last line. Piece of cake. String array, first element, second element, third element, fourth element, you know, so it's just an ordinary. Now I'm going to copy array to array plus 6, outstring. Okay, so string iterators. Stream iterators. Okay. So that's that. Let's see, we're done at 10:50, is that right? Okay, I'll stop here. I went a little over last time anyway, didn't I? Yeah, way over actually. So I'll stop here. A couple of things. So I'm going to start talking about the standard template library on Thursday. There will not be a help session on Friday. I haven't done my taxes yet. So Friday is when I prepare my taxes, okay? Weeping and wailing and gnashing of teeth because I always owe Uncle Sam a lot of money. Yeah. So my attitude is, why have Uncle Sam earn interest on my money when I can earn interest on my money? So I hold, you know, when push comes to shove, the penalty for underwithholding offsets any interest I earn, but it's the principle of the thing, you know. So anyway, no help session on Friday. There will be on Friday the 20th at 3 o'clock in this room. I haven't reserved this yet. I got to see Rebecca to try to reserve this, but I assume it will be. This is a summer projects meeting. And the summer projects meeting are just, you know, if you're going to be here in the summer and you're bored, you want something to work on, or better yet, you want to prepare for interviews. So I got this nice project that we built in OOD, and I want to really polish it up really nicely for interviews. Great time to do it in these summer projects. So the way that works is no registration. You don't pay anything for it. You don't get a grade for it. Of the summer, I spend 3 weeks with my family, the first 3 weeks in June normally. But all the rest of the time, I come in about once a week. So the 2 weeks after graduation in May, I'll come in, and then all of July and all of August, I'll be coming about once a week. And when I come in, I'll send out an email. I have a Piazza for summer projects, and you know, so if you've signed up for it, you'll get an email saying, I'm going to come in on Friday, or maybe it'll be a Thursday this week, or whenever. And here's what I'm going to talk about. And so I talk about whatever I'm going to talk about, and then you guys could talk if you want to. I think it's a really good idea, because if you get up and talk, you'll get, you know, a very friendly design review. Okay, nobody gets beat up, just very friendly. But you know, have you thought of? Well, suppose we did it. You know, that kind of stuff. So, nice thing to do. I've also talked about. I don't know whether I did in front of this class. I think at the help session, I talked about having a mock interview. Friday, right? Is that when I talked about it? I did talk about it. So for any of you that weren't at the help session, I'm thinking about doing mock interviews. It won't be, I'm pretty sure it won't be until after graduation, because I'm going to be pretty busy up until then. But probably that first week after graduation, we'll do mock interviews. And the idea is simply, you know, if you're interested, you come in, I'm the interviewer, and you know, you come in, shake my hand, hi, how you doing? And I start asking you questions, and I'll react to you like an interviewer would. You know, I worked in the industry a lot of years, and I managed 3 companies, and I hired a lot of people and did quite a bit of interviewing. You know, is this going to be like a Google interview? Probably not. You know, it's just my style of interviewing. You know, I've never interviewed Google, so I don't know their style. You know, but you know, I'll ask questions, and either in that mock interview, you'll either get hired or you'll be put on the bus. Okay, getting put on the bus is not a good thing. It says you didn't get past that round. Okay, that's what at Microsoft. That's what happened. You come in, and they have a slate of usually like 6 people you talk to, and if after the second person you get put on the bus, you know, wasn't good. You didn't do a good job. You know, so it's fine if after the last interview you get put on the bus, and everybody's really encouraging, so that's good. But that's my game plan. You know, if you're interested, let me know. If people aren't interested, I won't do it. But so anyway, with that, no help session this Friday, and we're going to talk about the STL details on Thursday, 2 days from now.
for the test, I just call my event handler in the Windows loaded program manipulator.
Okay.
Or I should write a separate class to do that.
If I were doing it, I would probably write a separate class, and you can write to the console. So I think that separate class probably would wind up calling event handlers, or, the equivalent of what's inside the event handler. Sometimes it can be a little tricky calling the event handlers in a way they're happy with. It's passing arguments, and if you don't pass in the right arguments, they won't be happy with you. So it can be easier, perhaps, to write a function that's doing what that handler does for your test, and then your handler just calls that function.
In Windows loaded, call this function.
Yeah. So in Windows Loader, right at the end, you just run through those tests.
And another test for the multiple client, I want to create a new project called Client Starter to start different process of the client, to which each one has different.
You could, but it's just as easy. See, in your run.bat file, if you say start client, you say start server, whatever the server name is, start client, whatever the client name is, and you just call start client again, a second one will pop up.
Yeah, but they will call the same client, but I cannot parse the argument as a different localhost phone number.
So if you provide on the command line the port number, okay, then you say start my client 8081. Start my client 8082.
Yeah, but
that takes care
the issue is the client started is loaded in window loaded, so the argument is the object and the event argument.
You can read the command line. So before you ever start it, what you do is you read the command line. The command line is accessible to you. There's a WPF function that'll let you get at the command line, and before you start the translator, before you start common the translator, you just read the port number from the command line, and you start it up on that port. That's all.
So I should figure out the function to how to call command line arguments.
Yeah, it's really simple. Just look up access command line from WPF, and Stack Overflow. There it is.
So we should do the multiple client in this way.
I would. That's the easiest way. I mean, you can build separate projects if you want to, but why?
Just change the port number in one client.
You can. You can have another project. That's perfectly okay. If that's what you want to do, you can do that.
Okay, thank you.
Yeah. Yeah, let me pack up, because there's another class coming in. Let me pack up, and we can come to my office and you can talk. Yeah, I'm tired. Why don't you come to the office hours? Because when you need go down a little bit, get a little bit to eat, and then I'm sure they can talk. Yeah. Is your question fairly quick?
复制了2遍，你让我看见。
这个是也是拆号的时候，它会出来一个 get 字儿。
你也是拆号。
我要自己运营。